Welcome back to the second part of the crane video. I'm determined to keep the crane size down by reducing the reach. So I'll add the crane inside the structure, box out a few members, and then move the crane out to erect the remaining members. Of course, one of my goals is to reduce the amount of placements required by finding the best location for as many lifts as possible. I'm going to go and add in the widely used Manitowoc 2250 and evaluate its placement at grid 17 in U. I named the crane. I'm going to go ahead and pick what my boom is going to be, a 140-foot boom. Let's put in a jib 132 at 40 foot, 5 degrees. I'm going to set my main to 4 parts of line and my whip is going to be 1. Now when I burrow down into my lift configuration, let's go and set my counterweight at 169,200 pounds. Let's go ahead and for the main line, we're going to give a 4,000 pound block, 300 pounds for the rigging, 15 for each of the remaining. For the headache ball, we're going to throw in 300, another 300 for the slings, and 15 for those remaining values. I would like to point out that this can be modified on each lift configuration, right down to each placement, right down to each lift. I'm giving the first placement for this crane a lift. Here I'm showing you how you can modify that configuration. The system is checking on the fly the feasibility of the set location of the lifts based off the following calculations: strength and stability of the crane, hoist capacity, so that's the parts of line, the reach radius, which is taken from the members or assemblies center of mass or gravity, lift height. When I rotate, you can see these blue rings and you can see that no lift area for both the boom and the jib. Now green indicates that the pick and set points pass. Orange is a critical lift as per OSHA subpart R, which is 75% of the rated load chart. Red, either the pick or set calculation has failed. Note, you can still add the failed lift to the crane's lift list if you disagree with the system. As I undo back to plan view, I'll finish by locating at axis 17U. Next, I'll orient the direction of the tracks. Now I will set the furthest laydown location or pick point for the crane. Note that this laydown can be modified for each lift. The same criteria is being used for the laydown point as well as used for the set point. To get the results I'm looking for, I'll set the point at 124 foot at 80 degrees outside of the structure. Then I'll finish by setting the boom orientation. On a side note, the data is correct, but the crane object you see is only a placeholder and does not depict the actual size of the crane dimensions except for the boom and jib length. By using the Show Liftable Members, I can see the liftable members at the selected placement and their lift conditions using the current crane configuration. I'm going to check the 343 C1 column, which was determined as our heaviest weight using this placement location. Again, I can modify the lift configuration, but I won't. We can see that the lift passes for the pick and set points. SDS2 uses the deductive method for its lift calculation. Some may use the additive method and some a combination of both. The difference between these methods will cause the difference where the 75% for the critical lift is at. We also do not use interpolation of the rated load charts as stipulated from our research. Finally, our sheave height, sheave to the underside of tracks. We do not take into consideration the 3% deflection on the boom and jib during the lift. Also concerning height, our check is done at the set and pick points. We do not look for obstructions along the way, nor do we consider the length of the rope between multi-lifts. The height is determined from the top of the lifted steel. I will assign this lift to the placement. I'm going to open up the Manage list for this crane placement. When I select a piece marked in a list, notice that the column is selected in the model. The same works vice versa. I can view the assigned member and of course all of its calculation data. I can also edit this member again, and I can modify the pick location or the lift configuration. I'm going to change this to a main line. It's from the whip, and we now have a critical lift. Since the pick governs, you can modify the pick location so the lift is not critical. I want to point out that you can assign failed lifts to a crane placement if you feel the lift can be made. After all, you're the boss. All this data can then be reported, but we'll see that later. It would take forever to select each member and add it to this crane placement. So, I will use the Assign Member Lifts to batch assign members to this particular placement. Using this tool, I can disable the ability to select members that are hidden or members that are failed or assigned to another crane placement. Once again, you have that lift configuration to refine this lift. I'm going to grab a portion of the building and then assign the members to this crane placement. I can see all the members listed with this placement. And when I select the members in the list, I see the members selected in the model. Time to go ahead and add that assembled canopy to this particular crane placement lift. There's all the data for the assembly and all the members that are assembled together. When I go to my Manage Lift list, we can now see that assembly. What about all the other non-steel lifts, such as decking, panelized joists, concrete panels, and so on? This is where the Assign Load lift comes into play. I can assign items like decking. I'm going to go in here and add a 3,000 pound bundle. I can modify the pick point, but I'll leave what I have and leave the configuration as it is. Then I will go ahead and set the bundle on the roof. There's the information for the lift. Go ahead and assign it to that crane placement. Look at Manage Lifts, and we now see the decking in that particular lift list. We can even do multi-lifts or Christmas treeing. Please note that the height will need to be evaluated with this as it was mentioned earlier. Select the members we want. Go ahead and assign it. We can see the calculations for the pick and set point, the members that are in that particular lift. I would add in another crane placement for this crane, but I think you get the gist of it. In short, each crane can have as many placements as required, and you can have multiple cranes and multiple crane types with multiple placements. You even have status filters that can show members with critical lifts, which can then be exported in a color-coded 3D PDF as seen in the earlier work package video. The maroon members are assigned to the placement and the orange member is the critical lift. Now to run a quick placement pick list report for this crane. This is just a pick list for this placement. It is not an ordered pick list. At least it's not an ordered pick list at the moment. Here are some examples of exported data from Douglas Steel Fabrication Corporation. Critical lift list report, defining lift list, and of course crane placement drawings. To finish up this video, I'm going to load a status filter that will show members that have been set to an erected status. When I edit a member, we can see that there are many settings that can be set by the erector. Note, these settings can be sent back to update the fabricator's model through an XML file, but I will only mention this ability due to time. Time to set some members with the status of erected. Using my update status, I will set my date. Notice how the status automatically color codes the model. I'll finish by running what is called the erected report. This will go ahead and give a weekly erection report for the entire project, which indicates the tonnage and the number of members erected. On a free note, you can pack up the project and an end user can install the free viewer to run reports, look at the status of the models, and review the information at no cost to them. This will conclude this video.